integration. There are three major themes in calculus: limits, derivatives, and integrals. And it's integrals that we're going to look at today. So we've got some new notation. This says, find the integral of the function 2x, where x is your variable. So when we took derivatives, we took them often with respect to x. Now we're taking the integral with respect to x. And what is the answer? X squared plus c. Now I hope you're looking at this and thinking, wait a minute, that's just the antiderivative. And yes, the integral is simply the antiderivative. So why the new notation? Mathematicians like things to be concise, and so this is just a way of simplifying and saying, find the antiderivative of the function 2x, where x is your variable. So we'll do exactly what we did in the previous section. You just have to get used to the new notation. Find the antiderivative of x squared minus 1 squared, where x is your variable. Now, think of all our rules. This one was not bad. We had number x exponent, but we don't have that here. And we are not ready yet to do the antiderivative of a chain rule. So we need to make it look like this one. We need to make it look like in the form number x exponent. So we can expand it. X squared minus 1 squared gives us x to the 4th minus 2x squared plus 1. Now that everything is in the right form, number x exponent, we can do what we did before with antiderivatives. Raise the power and divide by it. Raise this power, divide by your new one. This one is 1x to the 0. Raise the exponent to 1. And remember to add c because we want to get every possible solution. Doesn't look like there's anything to clean up, so we're done. The antiderivative of e to the 5x. Now that is not one of these rules. It is not in the form number x exponent. This is an e rule. And the e rules, if you remember going forwards, we'd write down what we started with and multiply by the derivative of the exponent. So going backwards, write down what you start with and divide by the derivative of the exponent. As long as you're only dividing by a number, this will work fine. When it gets more complicated, we're going to need to do something else. Now, this is a magnificent section for checking your work. If you want to know if you're right, simply take the derivative. The derivative of e to the 5x would be e to the 5x times 5, which would get rid of the 5 in the bottom, and we get what we started with. So we know we're right. Let's try another one. Don't recognize this at all. I wonder if we can change anything. Secant is 1 over cosine. So we're changing secant to 1 over cosine, and then cosine squared times 1 over cosine is just cosine. And then we can integrate that. We know the integral of 1, that's 1x to the 0, so raise the power and divide by it. And what has the derivative of cosine x? The answer should be sine x. Some more to do. Let's see what we can do with these. It's not in the right form. Much of what you're doing today is simply putting things in the right form. So what if we wrote it as x to the negative 3? Now it's in the form number x exponent. Raise the exponent and divide by the new exponent, and then make it look better. We tend to put the negative up top, and x to the negative 2 we'd write as x squared in the denominator. The integral of x root x. We are not ready for product rules going backwards yet. So we have x and x to the 1/2. And then we could add the exponents. That would be x to the 3 over 2. Now it's in the right form, number x exponent. So we'll raise the power and divide by it. And when you divide by 5 over 2, it's the same as multiplying by the reciprocal, 2 over 5. Let's just take a little look again at what we did. We wanted to write these in the form where we could find the antiderivative. And one of our basic rules is number x exponent. So we're not ready for quotients. We had to change it so it was number x exponent. We're not ready for products. We had to change it so it was number x exponent. We're not ready for quotients either. So what are we going to do here? We could divide everything by x. So if we do that, 3x squared over x becomes 3x. X over x is 1. 1 over x is just 1 over x. Now it's in the right form. Number x exponent. So raise the power and divide by it. This again, x to the 0. So raise the power to x to the 1 and divide by it. And I'm hoping you're starting to recognize 1 over x with the antiderivative is the ln of the absolute value of x. If you were tempted to do this one the way we did that one, you would have had x to the -1, raise the power to 0, divide by 0. You know you can't divide by 0, so that told you to go look at those list of derivative rules and see if we could find a 1 over x in the right-hand column and then back it up. Reminder again, why do we have the absolute values? It's got to do with the domain of the function. This one is defined for all values except for 0. If the absolute value bars were not there, this would only be defined for positive values of x. So to make the domains the same, we made it the absolute value of x. So one more time, what happened? We do not want to try and do the quotient rule backwards. So we changed it. We divided everything by x. 3x squared divided by x divided by x, 1 divided by x. Then it was in the right form, number x exponent. We took the antiderivative. And this one, we're learning to recognize that as ln absolute value of x. Now, if you're wondering, how hard can this get? Oof, all right, made it a little bit complicated. I'll show you where we're heading, just so you know how nice today's going to be with the easy ones. And we'll see what we're actually going to be able to do eventually. If we took a 2x, that would give us 10x and 7. And then perhaps you recognize this. What is the derivative of 5x squared plus 7x? 10x plus 7. So I wonder if this is just the ln of the absolute value of 5x squared plus 7x. Let's check it. 1 over argument, derivative of argument. And what about the 2? The 2 just hangs out. So this is where we're eventually going to go. So you need to get very good at the basic stuff. And you're going to do that on page 2. Do 1 to 24. The more you do, the better it's going to be. And then this is where we're heading next. Have fun.